Scene script. Have you ever wondered how the universe formed? The most widely accepted explanation starts with a bang, a Big Bang to be precise. In the grand cosmic story, the Big Bang theory takes center stage. This theory suggests that the universe, in all its vastness and complexity, began as a singularity, a point of infinite density and temperature, a point so intense, so packed with energy, that it defies our understanding of physics. Around 13.8 billion years ago, this singularity started to expand. This wasn't an explosion in the traditional sense, but rather, an expansion of space itself, and thus, from this tiny, intense point, our universe was born. Immediately following this expansion, the universe was in an extremely hot and dense state. It was a seething cauldron of energy, too hot for anything to exist in the form we understand today. But as it expanded, it also began to cool. As the universe cooled, particles started to form. The very fundamental building blocks of matter came into being. Within the first 3 minutes, the simplest and lightest elements, hydrogen and helium, began to form. This was a critical moment, a testament to the extreme conditions of the early universe. These nuclei of hydrogen and helium were the first steps in the creation of the matter we see around us today, but this was only the beginning of the cosmic symphony of creation. The universe still had a long way to go before it would become the familiar cosmos we see when we look up at the night sky. The early universe was a vastly different place than the one we know now. It was hot, dense, and filled with particles, a far cry from the cold, structured cosmos full of stars and galaxies we see today. It's hard to imagine, but that's where our story begins. So, in the beginning, the universe was nothing more than a hot, dense soup of particles. As the universe cooled and expanded, something remarkable happened. The first stars and galaxies began to form. Picture, if you will, a cosmic soup of particles, incredibly hot and dense. But as the universe expanded, it also began to cool. It was in this cooled state that atoms, the building blocks of matter, started to take shape. Hydrogen and helium, the lightest and simplest elements, were the first to form. Now, with atoms in the mix, gravity began to play a pivotal role. It started pulling these atoms together, and the first stars were born. These stars were not like what we're accustomed to seeing in our night sky today. No, these were behemoths, much larger and hotter than their modern counterparts. In the darkness of the early universe, these stars were the first sources of light, breaking the cosmic dark ages. But they didn't exist in isolation. Gravity, unrelenting in its influence, pulled these stars together into clusters. These clusters of stars, swirling and interacting, eventually formed the first galaxies. Just like the stars, these early galaxies were drastically different from the ones we see today. They were irregular in shape, without the distinct spiral arms or elliptical structures that we associate with galaxies. And they were teeming with young hot stars, making them incredibly bright. Over time, these galaxies evolved, interacting with each other, merging and sometimes even colliding. This cosmic dance, guided by gravity, led to the diverse array of galaxies we see today, from spirals like our Milky Way to giant ellipticals. So, from a dense, hot soup of particles, the universe had transformed. Where once there was uniformity and simplicity, now there was diversity and complexity. And where once there was darkness, now there was light. From a dense, hot soup of particles, the universe had transformed into a vast expanse dotted with stars and galaxies. Fast forward to roughly 4.6 billion years ago, and a particularly interesting event occurred: the birth of our solar system. This wasn't a spontaneous event, but a process that took millions of years, starting with a giant molecular cloud. This cloud was a vast, cold region of space filled with gas and dust particles. Under the relentless pull of gravity, the cloud began to collapse. As it did, it started to spin, forming a rotating disk. Picture a cosmic whirlpool swirling with gas and dust, spinning faster and faster as it contracted. At the very heart of this spinning disk, a protostar started to form. This was the embryo of our sun. Under the immense pressure and heat, nuclear fusion ignited, giving birth to our sun. It was a fiery, violent birth, but it marked a significant moment in the history of our solar system. Yet the birth of the sun was only the beginning. The remaining gas and dust in the disk didn't go to waste. These materials, under the influence of gravity and the sun's heat, started to come together. They began as tiny specks, sticking together as they collided. Over time, these specks grew into pebbles, then boulders, and eventually, planetesimals. These planetesimals continued to collide and merge, growing larger and larger. Some became the rocky inner planets, Mercury, Venus, Earth, and Mars. Farther from the sun, where it was cooler, icy planetesimals came together to form the gas giants, Jupiter, Saturn, Uranus, and Neptune. Meanwhile, smaller chunks of rock and ice that didn't quite make it to planet status became the asteroids and comets, the leftover building blocks of the solar system. And so, within a spinning disk of cosmic dust and gas, our solar system was born. A process of cosmic evolution that took millions of years, resulting in the fascinating, diverse system of planets, asteroids, and comets that we call home today. Among the planets in our solar system, one holds a special place for us: Earth. The story of Earth's creation is akin to an epic tale of transformation and resilience. About 4.5 billion years ago, our planet was born from the remnants of the swirling disk of gas and dust that once surrounded the young sun. As these particles of matter collided and bound together, they gradually formed a growing planetesimal. The heat from these numerous collisions, along with the decay of radioactive elements within the nascent Earth, caused our planet to melt, creating a molten sphere. The heavier elements, like iron and nickel, sank to form the core, while the lighter ones rose to form the mantle and crust. This process, known as differentiation, gave birth to our planet's layered structure. As the outer layer of Earth cooled, it began to solidify, forming a thin, rocky crust. But Earth was not quite the hospitable place we know today. It was a fiery world, with a surface bombarded by asteroids and comets, and an atmosphere filled with noxious gases. Volcanic activity played a key role in shaping the early Earth. These fiery mountains spewed out gases trapped within the planet, contributing to the creation of our atmosphere. But they also released another vital ingredient for life: water. It's believed that much of Earth's water came from the depths of the planet, brought to the surface by intense volcanic activity. Comets, too, are thought to have played a part in delivering water to our planet. These cosmic snowballs, made of water, ice, and rock, would have brought additional water to Earth during the heavy bombardment period, filling our basins and creating the first oceans. From a chaotic disk of gas and dust, our beautiful blue planet emerged. The formation of Earth, its oceans, and atmosphere is a testament to the power of natural processes and time. It's a story of transformation from a molten rock to a world teeming with life. But Earth wasn't alone. It had a companion, our moon. Let's delve into how this celestial body came to be. Picture this: about 4.5 billion years ago, a Mars-sized body, affectionately named Theia, was on a collision course with Earth. Theia, traveling at a tremendous speed, slammed into our young planet, resulting in an event of cataclysmic proportions. This grand impact was so powerful that it sent a vast amount of debris flying into space. But rather than drifting off into the cosmos, never to be seen again, this debris began to coalesce, drawn together by the powerful force of gravity. Over time, these fragments of Earth and Theia slowly but surely formed a celestial body, creating what we now know and love as our moon. So the moon we see in the night sky is a testament to a violent and chaotic past. From a singularity to a universe teeming with galaxies, stars, and planets, the transformation has been dramatic. The early universe was a hot, dense, and uniform sea of particles. It was essentially a cosmic soup of hydrogen and helium nuclei, swirling around in extreme temperatures. Fast forward to today, and the universe is vastly different. It's cooled down significantly and has become structured and diverse. The uniform soup has given way to a cosmic web of galaxies, stars, and planets, each with their own unique characteristics. The universe has also continued to expand, becoming more vast and more complex. This expansion is not just linear but is accelerating, a phenomenon that continues to baffle and fascinate scientists. The universe has evolved from a state of extreme simplicity to one of incredible complexity and diversity. From a point of infinite density to the vast, structured universe we observe today, the journey has been nothing short of extraordinary.